Okay guys, so we are doing the last section for chapter 5, which is solving equations with trig functions. You should definitely have your unit circle out for this, because that'll help. Essentially what we're going to try and do is we're going to try and get like you're going to try and figure out what obviously what solves this equation, what angle. Okay, so you want to kind of keep in mind that you want to get your trig function to be by itself, right? So you want to isolate your trig function. So any of the numbers, move that over to the other side. So that would be sine of x equals 1/2, okay? Now, if you're solving between 0 and 2 pi, okay, you want to figure out where would sine come out to be 1/2, right? Or at what angle is the y term 1/2, okay? And obviously you would figure out that then x would be pi over 6, and then also 5 pi over 6, okay? So typically you'll have more than one answer based off of the domain that you're paying attention to, okay? So as we jump into this first one, all right, it has a couple different parts. So it says find the solutions between 0 and 2 pi, 0 and 4 pi, and then for all real numbers. Okay. So you have 2 sine squared plus sine equals 1. All right, so it's probably going to make sense to put everything on one side, because then you can factor it. Okay, so I can make this 2 sine squared plus sine minus 1 equals 0. Okay, so what you have right now is like a regular quadratic. So 2a squared plus a minus 1 equals 0. So the same way that you would factor that is the same way that you're going to factor this trig function. Okay, so I'm going to break it up. So this would be 2 sine, and this would be sine, and then I'm going to make this minus 1 and then plus 1. Okay, so that's going to be the factored form. All right, so now what you want to do is you're going to set up you have two factors, so you're going to set up two equations. So you got 2 sine of x minus 1 equals 0, and then sine of x plus 1 equals 0. Okay, so isolate the trig function again. Same thing with the other one. Okay, so then figure out where would sine come out to be 1/2. So we actually just did that. So we know it's pi over 6 and 5 pi over 6. Okay, and then also where would sine equal -1? Okay, that's going to be 3 pi over 2. Okay, so those are your solutions. Okay, now this is just from 0 to 2 pi. Okay, obviously all those angles are going to be less than 2 pi. All right, now if you move on to the second part, right, this now says find all the solutions from 0 to 4 pi. Okay, well, we already know what the solutions are from 0 to 2 pi. All right, so solutions in 0 to 2 pi. All right, we already know that this is pi over 6, 5 pi over 6, and 3 pi over 2. Okay, now since we're going from 0 to 4 pi, right, we're adding just another rotation as you go around the unit circle. Okay, so all the angles that you're going to find after 2 pi are all going to be coterminal with the ones that you found originally. Okay, so all you really need to do for this is you're just going to add one rotation to each of these angles. So you're just going to add 2 pi to each of these angles. Okay, so when you do that now, right, So 2 pi is going to be 12 pi over 6. So the next one is 13 pi over 6. And then the next one after that is going to be 17. And then the next one after that is going to be, that's 4, that's 7 pi over 2. Okay, so all of these now are your answers from 0 to 2 pi. Okay, or 0 to 4 pi, sorry. You know, these are your first set of solutions, the first rotation, and then these three are your those are your second rotation. Okay, now if I did like 0 to 6 pi, right, I would just add another rotation to these three, right? 0 to 8 pi, right? I would just keep adding the number of rotations that I want. Okay, so when I move on to part C now, where it says all real numbers, all right, this is where you're writing general solutions. Okay, so it's you're gonna figure out like the first solutions in the first rotation. You know, from 0 to 2 pi. Okay, and then you're gonna write a general formula on how you would get the next one. Okay, so we figured out that the first one here was pi over 6, right? And then the next solution that we got was going to repeat 2 pi away, right? And then the next one would be another 2 pi, and then another 2 pi, right? So what I'm going to be doing is just going to be keep adding 2 pi every time to pi over 6 to get all of my solutions for that one. All right, so we're going to make this pi over 6 plus 2 pi n, and we're going to say n is a integer. All right, remember we did that notation kind of earlier in the year. All right, so then the next one is going to be 5 pi over 6 plus 2 pi n, and then the last one, 3 pi over 2 plus 2 pi n. All right, so those are your general solutions when you're doing it over all real numbers. Again, you can add like, you know, however many rotations that you want. You keep adding 2 pi to the original set of solutions, and that's how you get the general formula. Okay, so for number 2, this is algebraically find all solutions to that equation. Okay, so we're looking for all solutions, so that implies you're solving for all real numbers. So we're going to be writing general solutions. Okay. So again, what I'm going to do is I'm going to put everything on one side. Okay, and then what's, if you look at the equation, right, what do they have in common, right? They both have a tangent of x. So I'm going to factor that out. So that's going to leave me with root 2 cosine x minus 1 equals 0. Okay. So now your two factors are going to be tan x equals 0, and then root 2 cosine x minus 1 equals 0. Okay, so when I do tan x equals 0, right? Again, we're doing when the y term divided by the x term comes out to be 0, okay? So we know that this would be like at 0. This would also be at pi, 2 pi, and so on, right? So if you look at the distance, right, in between 0, pi, and 2 pi, it's always going to be 1 pi every time, right? And that's always what the period is for tangent, right, is 1 pi, right? So that's how you're going to get your general solutions, okay? So you can say the general solution here is going to be x equals 0 plus pi n. All right, and that goes back to the period of what your function is. Okay, and then the other one, you've got cosine x equals 1 over root 2, which is, if you rationalize it, root 2 over 2. Okay, so where is the x term equaling pi over 2, or I'm sorry, root 2 over 2? All right, that's going to be pi over 4, and then it also happens at 7 pi over 4. Okay, now because this one is cosine, right, we know cosine the period is 2 pi. When you write your general solution, it's going to be plus 2 pi n. And then the next one is going to be 7 pi over 4 plus 2 pi n. Okay, so number 3, find all solutions to 3 sine of u equals 2 cosine squared u, such that u is between 0 and 4 pi. Okay. So for this one, the problem that you're going to run into is you can't really factor anything right now, because obviously sine and cosine are 2 different functions, right? And you can't write sine in terms of cosine, and you can't write cosine in terms of sine, right? So you have to use an identity, okay? So that you, all right, so you're going to use an identity to write everything in the same function, okay? So you have to think about, like, what how could you write, what identity could you write cosine squared as, right? Well, you know that cosine squared plus sine squared equals 1, right? So then cosine squared must be 1 minus sine squared, right? So if I substitute that, right, this is going to be 3 sine of u equals 2 times 1 minus sine squared u. Okay, now everything will be turned in terms of sine. And then you can distribute and then put everything on one side. So you got 2 sine squared plus 3 sine minus 2 equals 0. And then you're gonna want to factor from that. Okay. So this is going to be then minus 1 and then plus 2 when you factor. Okay. So I'm going to write this over here. So you got 2 sine of u minus 1 equals 0. So that's sine of u equals 1/2. Okay. Now, again, we're doing from 0 to 4 pi. All right. So we have pi over 6 and 5 pi over 6. All right. So that's going to be the first rotation from 0 to 2 pi. And then when you do 2 pi to 4 pi, you just have to add 1 rotation to both of those answers. Okay, so that's going to give you 13 pi over 6 and then 17 pi over 6. Okay, so there you have that. And then the other one you had is sine of u plus 2 equals 0, which is then sine of u equals negative 2. Now, looking at the unit circle, there's no value that comes out to be negative 2. Okay, so this would be not possible. Okay, so this is your only set of solutions from 0 to 4 pi. All right, so you guys just, again, make sure you're paying attention to the domain that the problem is asking you for.